Hi everybody, welcome to this next video. So in this one, should be very quick. We're going to just go through standard form, a couple of the basics, and then go into some kind of quick questions that you might have in the GCSEs. Shouldn't be too long, so let's jump straight in. So the first thing you need to understand is what standard form is, okay? And so we need to think about what the correct format is. Now, what you need to remember is there needs to be a number, so any number, times by 10 to the power of something else. Okay, now when I say any number, I actually mean this has to be a number between 1 and less than 10. Okay, so for example, you could have 3.7 times 10 to the power of 5 would be in standard form. You could have 9.2 times 10 to the power of minus 3, that's in standard form, but you couldn't have 0.8 times 10 to the power of 2, for example. Okay, so the first two are fine, the last one there doesn't work. Then the indices, so this bit up here, the power can be any integer, it must be an integer, so it must be a whole number, and it can also be negative, and we'll talk through when you end up getting a negative as well. This is always times 10. Okay, so you're looking for a number between 1 and less than 10 at the start, and then always times 10 and then to the power of another number. So if we look at this first one, it says write this number in standard form. Okay, so this number here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 4,650 billion. No. So it's 4,650,000,000. Okay, that's what this number is. That doesn't really matter too much. You don't need to know exactly what number it is, but just to get your head around it. So the first thing I need to think about is how can I make this between 1 and 10? Well, at the moment my decimal place is there and I need to get it there. Okay, because that's between 4 and the 6, which makes it 4.65. So I couldn't put that decimal there because that would make it 46.5, which is not less than 10. And I couldn't move the decimal there because that makes it 465, which again is not less than 10. So my decimal has to go to that point there. So I know my answer is going to start as 4.65 times by 10, and then I need to figure out what the power is. Now the power is basically how many decimal places are we changing? 1, 2, 3, 4, 5, 6, 7, 8, 9. So your answer is 4.65 times 10 to the power of 9. Now, sometimes this number at the top, this indice, will be negative, and we'll talk about why that is in a sec. But basically, if it's a really big number, so as I say, this number here is a fairly big number, 4,650,000,000 is a pretty big number, your indice will be positive. If it's a really small number, like this, for example, like 0 point something, then it becomes a negative. Okay, so if it's a number less than 1, if it's a decimal, 0 point, whatever it might be, your answer will be a negative power, and if it's a bigger number, it becomes a positive power. Okay, so let's look at this one. You can pause the video, have a go at this one if you want to, or you can just wait for me to go through it. So again, I've got to get my decimal to there, so it's going to become 7.23, and then counting how many places I need to move, 1, 2, 3, 4, 5, 6, times by 10 to the power of 6. That would be the answer there. So using the logic, you could also look at this next one. So at the moment, the decimal is currently there, and I need to get it to 7.3. So I know my answer is going to be 7.3 times by 10. Now I'm thinking, how many times have I had to move that decimal? I've moved it twice. But in this case, because that's a really small number, it's 0 point something, it becomes minus 2. Okay? Pause the video again if you want to and have a look at the last one. But again, here we go, it's going to become 5.2 times by 10. How many spaces are you moving it? That's 4 spaces I've had to move, and because it's really small, it becomes minus 4. Okay, so that's your premise of standard form. You could also get asked to convert from standard form into a number. So for example, if I gave you 3.8 times 10 to the power of 8, and I said you turn that into standard form, the best thing to do is to take the 3.8, so write the 3.8, and then using that power, add some zeros. So I've added 8 zeros there, okay? But then you've got to think to yourself, I need to move this decimal 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So my decimal place has to go there, and then rewrite that number as 3, 8. 1, 2, 3, 4, 5, 6, 7. So I write my 7 zeros. And then to figure out where your commas go, start at the end, go back 3, put a comma, back 3, put a comma, and then you know that that number is 380 million. Okay? You could also get asked to do something like this, 4.2 times 10 to the power of minus 5, for example, and the process would be exactly the same. So I'd write my 4.2, but because now this is a negative indice, I know that my decimal is going to be moving the other way, so I put my zeros, so I'm putting 5 zeros there before the 4, and then again move my decimal 1, 2, 3, 4, 5, put my decimal in there, and then rewrite it 0.0000042. Okay, so they're your two ways that you can go from standard form into a proper number like I've just done, or from a proper number into standard form. Okay, next bit, it could be that you're asked to multiply with standard form or divide with standard form. Now, quick shortcut, really quick way of doing this. If you're asked to multiply, you do the number times the number first of all, so 4 times 3, which is 12, and then times 10 to the power of something is what my answer is going to be. And remember what your rule is. This is multiplying with indices effectively. I've got 10 to the power of 7 times 10 to the power of 2. You add the indices together, so that becomes times 10 to the power of 9. However, those of you that would have spotted this quite quickly, this first number here is not less than 10. At the moment, the number's 12, and my decimal would be there. So here's a quick way of thinking about it, a bit of a shortcut. I've got to move my decimal down 1 here. So I move it down 1, so it becomes 1.2. And if I go down 1 there, at this point here on the indice, I go up 1. So it now becomes times 10 to the power of 10. Okay, so if when you work this out, you notice that this number here is above 10, you need to move your decimal down 1, which means you then need to push this up 1. And if it turns out that your decimal here is actually less than 1, you would have to go up 1, which means you then go down 1 here. I'll show you at a later date what that looks like. So think about what happens here then. So this is now division. So I can do 9 divided by 2, which is 4.5. And I'm happy with that number because that is actually less than 10. It's still going to be times 10 to the power of something. But now you need to think about, if I'm dividing with indices, what actually happens with the indices. And where we multiply up here, we add them. With division, we subtract. Okay, so you're doing minus 2 minus 8, which gives you minus 10. Okay, so if you're asked to multiply, do the numbers first, then deal with the indices and double check that that is less than 10. If you're asked to divide, do the numbers first, exactly the same, and then deal with the indices afterwards, and again make sure that that number there is less than 10. Final two examples that you might have in context, so we'll look through these two now. So the first one says find the volume of the shape, give your answer in standard form. So to find the volume of any shape, you find the area of the front and then you times it by how far back it goes, or area of a cross section times by height or depth. So what I'm actually doing is 0.05 times 0.02. That's the area of the front first of all. Now I know 5 times 2 is 10, but you need to make sure that actually there are 4 decimal places in this question. So when I'm working that out, I should then have 0 point and 1, 2, 3, 4 decimal places. Now I already know that 5 times 2 is 10, so the 1 and the 0 make up 2 of those decimal places. I can then add another 2 on to it. And then finally, what I then need to do is times that by 0.06. Now, I know that 10 times 6 is 60. But again, if I look at this question, there are 4 decimal places there and 2 there, which means 0 point, because there's 4 decimal places here and 2 here, 1, 2, 3, 4, 5, 6. I must have 6 decimal places. Now I already know that the 60 takes up 2 of those, and then therefore the rest of these become zeros. Okay, so let me just quickly recap that. 5 times 2 is 10, but because there's 2 decimal places there and 2 decimal places there, in total I have 4 decimal places, so 1, 2, 3, 4. The 1 and the 0 take up 2 of those, so fill it with zeros for the other 2. And then you're doing that, because that's the area of the front, times by the depth. 10 times 6 is 60. There are 4 decimal places there and 2 decimal places there, so in my answer I have to have a total of 6 decimal places. 60 makes up 2 of those decimal places, so I fill it with zeros before it to make up the whole 6. Okay. Now I need to turn that into standard form, so we're basically going back to what we did up here. To turn that back into standard form, I know that it has to be between 1 and 10, so it'll be 6, effectively 6.0, so I can just write that 6, and then I move my decimal 1, 2, 3, 4, 5. So 6 times 10 to the power of 5, but because this is a really small number, minus 5. So that would be your answer. 6 times 10 to the power of minus 5 is the volume of that shape. If it asks you for units, because it's volume, it would be meters cubed, because these are all in meters, and that's meters cubed because it's volume. Okay, if you're not sure about volume, I have done a video on that, you can go back and check it. And the last one here is looking at speed, distance, time. It comes up quite a lot with standard form, puts it into context. So the speed of light, so we've got speed here of light is 3 times 10 to the power of 8 meters per second, and that value has been slightly rounded because it's not exactly that. The distance from the sun to the earth is 150 billion, that is 150 billion meters. Work out how many seconds it takes for light from the sun to reach the earth. Okay, so if we're looking at this is a speed, distance, time question. So speed, distance, time. That's my formula triangle. You may have seen that in science. Just remember that multiply there, divide here. So if I was finding distance, cover it up, so you do speed times time. If you're finding time, cover it up, you're doing distance divided by speed. If you're finding speed, it's distance divided by time. So in this one, I'm actually being asked to find how many seconds, which is time. So I know time is equal to distance divided by speed. Okay, so we know that the distance is 150 billion meters. Now, because my answer needs to be in standard form, I'm going to convert this 150 billion into standard form. So I know it's going to become 1.5, and then my decimal is currently there, so I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So times 10 to the power of 11. And that value is going to stay positive 11 because that's a very big number. So 1.5 times 10 to the power of 11 divided by, I've already got my speed in standard form, so 3 times 10 to the power of 8. Okay, so what we now need to do is basically work this out. So let's ignore the times 10 to the power of 11 and times 10 to the power of 8 for a second, and let's just deal with the number. So what you're basically saying is 1.5 divided by 3. Okay. Now, if you struggle to do that with decimals, what you could do is turn the 1.5 to a whole number. So you could times that by 2, so you actually end up with 3. And I could times this by 2 and I end up with 6. So the same sum is 3 divided by 6. Well, if I wrote 3 over 6 as a fraction, 3 divided by 6 is actually the same as a half, which is 0.5. So 1.5 divided by 3 is actually 0.5. The other way you can think about it is 15 divided by 3, which would give you 5, and then you've got to put your 0 back in. Okay, so a couple of different ways you can do it. This is quite a nice method to work with decimals. Alternatively, you could have said 1.5 divided by 3. Well, if I times that by 10, I get 15. So I times this by 10, and I get 30. So if you did 15 divided by 30 as a fraction, 15 over 30 again would still give you a half. Okay, so that's just a side note on how to divide with fractions if you're not 100% sure. Divide with decimals, sorry. So I know the first bit's going to come 0.5. I know it has to be times 10. And remember what we did previously at the top. What happens if I'm dividing with indices? Well, I subtract, so I'm doing 11 minus 8 3. So it's 0.5 times 10 to the power of 3, which would pick me up a mark in an exam, but there's something wrong with this. This value here is not between 1 and 10. So as my final step, I need to make that number between 1 and 10. So I go up 1 here. So now that decimal has moved up 1, so it becomes 5. And therefore, what I do here is I go down 1. So that now turns to a 2. So again, that's a little shortcut for you to remember. If you move your decimal up 1, you go down 1 with the indices. And as I said previously, if you go down 1, you go up 1 with the indices. So that is 5 times 10 to the power of 2 seconds. Okay. Now, if it said give your answer as a whole number, 5 times 10 to the power of 2, well, 10 to the power of 2 is 10 squared, which is 100. 100 times 5 is 500. So it actually takes 500 seconds for light from the sun to reach the Earth, so which is 8 minutes and 20 seconds. So by the time anything happened with the sun, it takes 8 minutes and 20 seconds for the light to actually reach us. Okay, so that's standard form. They're your basics. They're the things you need to be aware of, especially coming up to your GCSE. So make sure you're happy with all those fundamentals from the top there, all the way through to multiplying, dividing, and then some questions in context. I hope you enjoyed it, and I'll see you all in the next video.